Zen and the Art of Telemetry, an inquiry into performance. Hi, I'm Anthony. I'm on the desktop performance team, and today I'll be talking about telemetry and how you can use it to answer your questions. The desktop performance team has two main goals: to find slow things and to fix them. We focus mainly on Firefox Desktop and the Gecko platform. So telemetry is our measurements and analytics platform. It includes everything from the code that ships out in your browser to the data aggregation pipeline, all the way to the tools that put numbers on a web page. So it's actually gotten a bit of an overhaul lately. Go check it out on telemetry.mozilla.org. So many of us benefit from real-world numbers to back up our intuition. But in the past, this has always been a little bit hard to come by. The tools were hard to use, and they couldn't always answer our questions. The new and improved telemetry tools bring the data closer to the people who need it. For example, here's the new histogram dashboard, which lets you view distributions of telemetry probes in multiple different ways. Browser as user default is a telemetry probe that is 1 if the browser is the user's default and 0 otherwise. So in the histogram, each bar in the graph represents the number of values that fall within that range. So to get the default browser frequency, we just read it off the bar. So this one's a little bit more complicated. We want to see how E10S builds stack up against non-E10S builds in terms of startup time. So Simple Measure's first paint is a telemetry probe that measures how long it takes for the first window paint to occur, so basically the startup time. So if we select Compare by E10S setting, you can easily see how they look next to each other. And from the histograms, you can tell that the E10S builds on nightly 42 are slightly slower than E10S than non-E10S builds. So the specific values here are around 2.4 seconds for non-E10S and 2.7 seconds for E10S. So let's try something a little more interesting. In our system, there's a concept of a keyed measure, which is basically a measure that can have submeasures, each of which can have their own histograms. So in this case, our measure is blocked on plugin instance init ms, and each key in this measure is the name of a plugin that blocks the main thread when it's instantiated. So here we've chosen to sort the keys by median value. So that means we show the top 4 main thread blockers for initialization. And unsurprisingly, it's Silverlight and Flash. Java also makes an appearance lower in the list. So there's also the evolution dashboard, which is intended to answer questions about how values change over time. So in this case, we're plotting the average value of the browser user default flag we saw earlier. And the advantage of this is that you can see how they change over time. You can see long-term trends in how everything changes. And over here, you can see that it consistently stays around 70% on nightly. So this is useful for finding like regressions, the impact of changes, and so on. So unfortunately, we can't answer all questions with just dashboards. We also made telemetry.js, which is the JavaScript library that we use for accessing aggregate data. You can also use it with Node, or you can just import it onto your web page and start using it right away. We have pretty good documentation, I'd say, and you can get started with less than 5 lines of code. So one of the cool things we're doing with telemetry.js is the automated histogram regression detector. So every day we collect all the data that we've gotten, we look at how it's changed, and we can use that to find performance regressions automatically. No human intervention required. So even with the raw aggregated data, that's sometimes still not enough. Sometimes we need access to the individual submissions from each user. Let's say we were wondering if the moon was causing the browser to start slower. This is a toy problem, but it does make for an interesting demonstration of what's possible. So we've got a super slick custom analysis platform set up. It uses Spark and IPython, and it's all running on Amazon Web Services. Anyone with a Mozilla email can use this. So that's the site, telemetry-mozilla.org. Log in, request a cluster, and wait for it to start. We'll provision the servers, set up the environment, and basically make everything set up properly in just a few minutes, and you can just log in. We're going to skip over to where it's all set up now. So there's already a few example notebooks in our environment, but we're going to start from a blank one. First, we'll need all the libraries we'll be using. So there's matplotlib, numpy, and our custom telemetry Spark bindings, which we import there. This is what we use for accessing the raw pings. So now we're going to actually obtain that raw data. We'll be taking 10% of submissions from July 5th to August 5th and extracting the client ID, startup time, and calculating the moon phase for each one. We'll also be taking only one submission per client ID to make sure there's no bias from the clients duplicating submissions. So it's actually pretty easy to do the calculation. It finishes in about 10 minutes, which is pretty fast, all things considered. So now we have everything we need to actually calculate the correlation. It's pretty simple to plot it now. We can make a scatter plot, and NumPy has a really convenient method for calculating correlation matrices, so we'll just use that. You can tell from the plot that as you move along the horizontal axis, the distribution doesn't really change. So that's evidence for the variables being independent. So what does that mean? It means that the moon is probably not slowing down Firefox. Good to know. The tools that make this analysis possible are powerful enough to do a whole lot more. So that was a really quick overview of what's possible with telemetry. There's a lot more to it. There's a lot of details. Those are some links if you want to do some reading. And yeah, thanks for listening. I'll be taking questions now. Yes. There's one over there.
Okay, so that's cool. What's the difference between, like, I wasn't really clear on the difference between the JavaScript API that you showed and like the Python notebook that you just showed. Like, both of them seem to be oriented around letting you do custom analysis. But
Just repeat the question.
So the question was, what's the difference between telemetry.js and the data we access through custom analyses? And the difference between those is telemetry.js accesses aggregates, so like everything combined together. So you lose a lot of information in that process, but it's really useful for things like dashboards. On the other hand, custom analyses access the raw pings that like individual users send us. So that's all the data we have.
so the JS stuff, like the aggregations, are stuff that you've chosen or other people on your team have chosen to aggregate?
Basically, yeah.
Okay.
It's like histograms and simple measures.
Hi. So, good talk. I think at one point you talked about notifications and that you could automatically detect whether or not there were performance regressions. Is that something where you can sign up for notifications? Can I specify my own thresholds? Can I piggyback on anybody else's probe, or do I need to implement my own? What's the bigger story there?
That's actually called Medusa. It's on alerts.telemetry.mozilla.org. And you can sign up, anyone can sign up to receive alerts for all of our regression detectors. It's a centralized email alert system.
Okay, I have another one also. So one of the challenges that we had with telemetry a while back was that I would add a probe, and it would have a cryptic name like Simple Measures First Paint, and no one else would be able to decipher what that meant, and so they wouldn't be able to reuse the data that I was collecting, and maybe we'd then not use the data, or we'd think we have to go and add another probe that measures essentially the same thing. Have we dealt with that at all? Do we have descriptions on these? Like, how would I go in and start browsing the available probes that are there today to see what it is that I would want to do?
I'll field this one. I don't think I'm on screen. This is Vlad, manager of probe team. Every probe has to have a description, like a human readable description, and the probe descriptions also show up in dashboard. They show up in histograms.json, so it should be pretty easy to search for keywords. But I think maybe what would be useful, for example, is also a way to tag the histogram definitions in histograms.json. So, for example, people could look for, hash startup, hash performance, hash graphics, whatever. I think that'd be a useful feature. I think it'd be actually very easy to add because really it's all just like adding meta tags to lines in that file. It doesn't even have to be processed. Maybe that's like a small project that we could do.
Okay. So that will help people look at what's already there and what they can use. And when they're thinking about what's new that they could add and use telemetry to add to the system, is there general guidance about the types of things that are appropriate to measure with telemetry versus things that are not appropriate that telemetry is not really built to handle?
So telemetry primarily, at least today, is histogram data. So if you have, numerical samples, then you can use telemetry for it. Basically any new feature or you release should have, measurements for performance, for correctness, error rates. And what's nice is with that centralized email system, you immediately get feedback. You get emails when something changes. Maybe you regress something, and the error rate goes up. You'll get an automatic notification. So, in general, more telemetry is better. Things for which telemetry is not currently well suited for, but could be adapted, because telemetry fundamentally is just a way to send data from Firefox installs to Mozilla. Let's say you want to do, some sort of what do you call it, funnel testing inside the browser UI. You want to see like how many people end up clicking on the Firefox context menu, how many of them open options, how many navigate to the advanced pane. That kind of stuff you can still do with custom analyses if you have probes for each of those steps. But it could be easier to do, for example, if we had some JS libraries to help with. But basically, you can make telemetry whatever you want it to be, and you should.
And that's the regression detector.
What am I looking at?
These are regressions in histograms. So we're looking at the distribution of histograms and how they change over time. And if the change is too large, you'll get a notification.
If I could just jump in for a second, what those histograms are showing, so this alerting system works on nightly channel only. The red line is the current nightly build on which the regression was detected. The black line is the previous nightly